Medhavi AI, from Sanskrit, meaning intelligent or intellectually brilliant. The perfect name for our AI-powered intelligent learning systems. The prompt that generates this sim. Claude Code Terminal. Claude I, write a Manim scene. Photoelectric effect on sodium, Phi 2.28 eV. Fire photons at red, green UV. Eject only when h nu exceeds phi. Speed as root of h nu minus phi. 3 things every prompt must pin down. The rule, the numbers, what to render. The CLI writes the file. Before you run it, read it. Find this line. Max of 0, E minus PHI. That is the entire physics. 1 subtraction, 1 clip to 0. Check phi is in electron volts. E is 1240 over lambda. The max enforces the threshold. 30 seconds. Not optional. Run the sim. 2 things to verify. Red and green are blocked at any intensity. The below threshold chip confirms it. UV ejects and the velocity arrow scales as root of kinetic energy, shorter near threshold, longer above it. Both correct. Note it. You are about to iterate. Iterate. Claude, update photoelectric.py, velocity arrow scales explicitly as root of h nu minus phi, print k in electron volts under each electron. Submit. Read the diff. Rerun. Prompt. Read, run, check, change. The physics was the excuse to run the loop once. New segment. Prompt. Claude, write a Manim scene, Compton scattering at 0, 90, 180 degrees. Show photon and recoil arrows. Label delta lambda equals lambda c times 1 minus cosine theta in picometers for each case. Geometry, formula, all 3 cases. The more you specify, the less you correct. Read the file. Find the formula, lambda c times 1 minus cosine theta. Check the constant, 2.426 picometers. Check that cosine receives radians, not degrees. The CLI usually nails the formula. It sometimes misses the unit. The read step is where you catch it before wasting a render. Run it. 2 checks. At 0 degrees, delta lambda is 0. The photon passes unchanged. At 180, delta lambda doubles. The photon fully reverses. These are the boundary cases. If either fails, the formula is wrong. Both hold here. The collision geometry is sound. Check done. Iterate. Claude. Update Compton.py. Animate scattered arrow length proportional to delta lambda, stretched visibly for 90 and 180 degrees. 1 diff, 1 rerun. You are not studying Compton scattering. You are getting fast at the loop. That is a different and more durable skill. Final segment. Prompt. Claude, I write a Manim scene. UV Catastrophe. Planck versus Rayleigh-Jeans on the same axis. Normalize so Planck peaks at 1. X-axis is HNU over KT, T equals 3000 Kelvin. Specify the normalization explicitly. Otherwise, the curves live on different scales and the comparison tells you nothing. Read the file. Find the Planck function. X cubed over e to the x minus 1. Find the normalizer. Divide by the peak value at x equals 2.821. No normalizer means the y-scales differ and the comparison fails. That is the one line to verify before you render. Run it. 2 checks. Curves agree at low x. Confirmed. Rayleigh-Jeans diverges while Planck stays bounded. Confirmed. At x equals 6, classical exceeds Planck by over 150 times. Infinite energy from a warm object. The machine showed exactly why classical physics could not be the end of the story. Final iteration. Claude A, update blackbody.pii. Add a ratio label at x equals 6. Rayleigh-Jeans divided by Planck. 3 simulations. 12 beats. Prompt, read, run, check, change. That is the real. The physics floated by. The loop is what you take with you. Medhavi, AI-powered intelligent learning systems. On YouTube at Medhavi AI, medhavi.com.